So, cross post to more pages. Hello everyone. Just kind of file in as we get started, waiting for more people to arrive. Where does this take us? Okay. Huh. So now I gotta go all the way to our Facebook page so I can share this with our group. Everyone that's coming on in, hello, welcome to Digital Inclusion Week. My name's Anthony Hake, and I'm the first presenter. I'm going to be doing DIY with Raspberry Pi. Sorry if I don't seem like I'm all here right now. I'm just trying to make sure the stream is posted everywhere it needs to be. There we go. Let's share this. Copy link. And let's take this to our event page. Awesome. All right, cool. The live stream link is out there. It's in the Facebook event page. So if you got some friends that you're expecting to hop in, just kind of direct them to that group page. And I can also share the event link in the discussion here, so you can copy and paste it, shoot it off to your friends. There we go. See if I can just throw that in the comments. Sweet. So you copy and paste that link right there, share it to anyone that you want to join the conversation, and they'll be able to hop on in. I don't have anyone physically present yet, so I'm going to take my mask off. But when someone does show up, that's coming back on. And when they do show up, I want them to be able to see what you guys are seeing. So I'm going to put it up on the big screen here. Alright, so let's go on over to discussion. Now there might be a slight delay between. Oh man, I already look so animated. See what you guys are seeing, so I'm gonna put it up on the big screen here. And perfect. Awesome, cool. Everything is situated. I'm going to give it 5 more minutes for people to kind of file in, and then once we hit the 6:10 mark, that's when we're going to start rolling. Maybe I can put out some posts, some polls, shall we? All right, let's post to more pages. All right, while we're waiting for people to come on in, I'm going to do a quick audio check. All right, while we're waiting for people to come on in, I'm going to do a quick audio check. Oh no, it's on the wrong sound. Hold on. There we go. Now it's coming to my headphones. Alright, I'm going to go ahead and mute that because that's meant to be a display only. Alright, looks like all of our equipment is fully operational. Let me get a... Alright, we got 3 minutes till we start. To make it more personal, if you guys want to introduce yourself in the comments, just so that I know you're alive and well. It is a little awkward for me to be talking to an empty room here, but I guess this is the new normal. Was that important? Was not. We're already on, Pat. I'm just giving people a moment to, get situated. And put my phone on silent. I am a terrible presenter. Alright. Alright, hello George. Glad you can make it. Let me clear out my screen here so I can be a bit more organized. Oh, cool. Hi, Ryan. Glad you can make it. Junior in Computer Science. You made it here from YPH. That's the organization I used to be a treasurer for. Fun fact. Keep your ear to the ground for Hake YSU. I think it's going to be virtual this year. Okay. Audio looks good. Video good. I suppose the real kicker is going to be when I have to switch back here. We'll see how that goes. Hi Ian, and effectively hi Jordan. He's asking me about my blue hair. If he wants to know, it grew like this naturally. Just woke up one day and there was blue in my hair. Hello, Ian and Jordan. Alright, T-1. We got 1 minute left on the clock. Got 11 attendees so far. That's not bad. Let's get those numbers up, though. Come on, last chance. Bring your friends in. We're going to talk about a lot of cool stuff today. And if you can't make it for today's talk, we're doing this Tuesday, Wednesday, and Thursday, so... Alright. We have officially hit the 10-minute mark, so I'm going to start talking. Well, first of all, Let's give a little bit of background about Digital Inclusion Week. This is actually an initiative put forth by the National Digital Inclusion Alliance. We just kind of work with them as a more local, on-the-ground host to help facilitate some of their programming. And Digital Inclusion Week is all about getting you in on the conversation of technology. There seems to be a growing gap of people that are really good with tech and those who are really good with the tech that they grew up with, but it's quickly becoming an antique, it's quickly becoming outdated, and they have to kind of relearn technology as it's much different from how it used to be before. So the Digital Inclusion Initiative is all about bridging that divide, helping people who are kind of stuck in that gap or from another era come on over and join us in the modern era. And Digital Inclusion Week kind of leaves it a bit more up to interpretation for the hosts. What we do here at Oak Hill Collaborative is we do a lot of educational programs, and we consider this to be kind of like a highlight reel of some of the stuff that we teach at the collaborative. As what I'm going to be talking about today, the Raspberry Pi microcomputer, you can use this in a variety of different projects, and that's what we're going to talk about today. But what we actually use Raspberry Pis for is a after-school program at the inner city schools here in Youngstown. So it's kind of like to get your foot in the door, and then you learn that we do a lot more with Raspberry Pi. And we also have other presenters who share stuff that they're very passionate about. We have Steve Kristen coming in tomorrow to talk about digital safety and awareness. Specifically, parents should be concerned about children data and the data that they are sharing on TikTok, stuff like that. And Tuesday and Thursday, we have Chris Palmer and Adam Nickels doing Sonic Pi and 3D printing. So if you didn't make it to this one, or if you like what we do here today, by all means, go to the other ones, please. It took a lot of work to get these presenters in here, but we're hoping that the content they're putting down is interesting enough for you to stay for the whole ride. And without a further ado, we're going to switch on over to my presentation. Let's see if this works. All right, I'm waiting for the live stream to catch up, I think, but it looks like when I hit present here, I go full screen. All right, so do it yourself with Raspberry Pi. If you didn't know what DIY was or what it stood for, that's what it is, do it yourself approach. It's an acronym that's used a lot on places like Etsy, where you make your own crafts and then sell them. It's also an approach taken a lot when working on your home, and we'll go over in depth about those examples more on as we move forward. Quick agenda. This is what we're going to be talking about today. What is DIY? I kind of briefly, went through that, but we're also going to give some examples of DIY, the do-it-yourself approach. And we're going to be talking about what exactly a Raspberry Pi is, as there may be some people in this chat that know exactly what a Raspberry Pi is, and maybe have even done some projects with them. I know that I've done a couple. And there may be some folks at home that think I'm talking about a pie, like a pie that you eat. So we're going to make that clarification before I dive into the project showcase. And I have 4 projects with me here today that I'm really excited to talk about. And as I present them, I'm going to go through kind of my thought process, my DIY approach that I took to develop them. And of course, we'll have a moment to stop for questions and whatnot. And if you have any questions and don't think that you'll remember them by the end of the presentation, just put them in the comments section. I'll get to them when we get to the Q&A section. All right, so we talked about the DIY or do-it-yourself approach. And I already went over that this is an acronym used a lot when you're selling things. It's not really thought about like this often, but it can be considered a more personal form of project management. Project management is a skill that is used a lot in business. There are people who use project management as their job, like that's what they do. Every day they check on projects that they've put in charge of. Or maybe they have a regular 9-to-5, and they're so good at that people also give them, you're really good at this, so we're going to make you take charge of this project. What we're talking about here today is project management, where you are the judge, the jury, and the executioner. You're making the decisions, you're making the calls, and you're implementing the solutions. And we're going to go over a bit more of that process. The process of project management, I feel, can be interpreted a lot of different ways. Everyone has their own unique way of doing things. So looking at this list how I've broken it down personally, as you can see, it's already different from the clip art that I threw in there about project management. They have 4 steps, I have 5. I recommend that you realize there is no correct way to really break down the phases, as some of these can realistically be collapsed into each other, or they can be merged. But when I approach a project, I start with brainstorming. When I brainstorm on a project, I think of all the potentialities. I think of what exactly am I doing here, and where am I going? How am I going to get there? That's brainstorming, in my opinion. It's different from planning in the sense that planning is the road work that you're putting down to get there. Brainstorming is figuring out where the road's going to go, so to speak. Planning is a step that has to come after brainstorm, because you cannot plan without having an idea of what you're doing. It's kind of your plan of attack of how you're going to implement what you've brainstormed. And this brings me to the next step, implementation. And if you look at the little clip art on the right here, well, my webcam's blocking a good chunk of that, I realize now, but no biggie. The do section, the do, the implement, the initiation, the developing, these are all words used to describe whatever action it takes to bring your idea to life. And someone mentioned that they're here from Youngstown Penguin Hackers. What we really focus on is the implementation part. As a matter of fact, at Hack YSU, our whole goal is to give you all of the brainstorming resources, all of the planning resources, so that you can start implementing from the get-go and have something made within 36 hours. Implementation is also very dependent on how large your project is. Like if this project has multiple parts that are dependent on each other, then you may go through this process a couple of times, meaning that you brainstorm, you plan, you make something, and then you realize as you're making something, you need something else. You need another pre-prepared ingredient. So you go back to the brainstorming phase. How am I going to make this component? And then you throw that back into the implementation. So you loop around a couple times. And finally, when you think you have a finished product, you test it. Testing is simply just putting it in an environment where it's going to be used. And this could be like a simulated environment where you can test it how you think it's going to be used. Or if you are daring, you can also do what's called testing in production. This is where you let real users in the real world use the thing that you've made, and then they report back to you with stuff that they've found. This is used a lot in beta testing, although I would say that's a more controlled version of it. In testing in implementation, testing in production, you are really hoping that what you made was done correctly, because anything that you did incorrectly will come up in that test, and it'll make you look like you didn't anticipate this, you didn't plan for this, and might reflect poorly on you as a project manager. But depending on how personal the project is, that might not be as big a deal as I'm making it sound. And finally, there's the revising part. Revising comes after testing, when you take in the data that you've received from your beta testers, the people that you let play with the thing, and you make improvements based on these considerations. All right, moving forward. Now, a couple examples of DIY, and there was a slide earlier that said we do DIY without even thinking about it. And a good example of this is painting a fence or building a fence. A lot of people don't think about all the work that goes into constructing, building, painting, priming, making sure it's weatherproof. These are all different considerations that you bring up in brainstorming, that you make a plan of action for, and then implement, because you have to actually go out and paint the fence. You can't just talk about how you're going to paint the fence. Another example of DIY that's become really prominent as of late is face masks. Now these here look like YSU ordered them from somewhere, But a lot of people, as of late, they've been making their own face masks using 3D printed plates, special sewing tools, and so on and so forth. I can't think off the top of my head all of the tools that go into making a face mask, but because there are so many people making custom designs, selling them on Etsy, there's definitely like a machine involved there. Or they can be doing all of this by hand. The build quality of those done by hand, I personally won't vouch for, but I don't know. Take it with a pinch of salt. And finally, we come to our last bullet point here. The example of DIY that I'm going to be showing in the showcase here is electronics projects. This is really prominent in the electronics community because how you test your knowledge of electronics is with projects. Usually electrical engineer majors will have this portfolio of all the robots and computer-based projects that they've worked on to show their aptitude. Now, this may not apply to you. You may just be, let's say, the average dad who has a man cave and wants to build an arcade cabinet in their basement. DIY comes in at multiple angles here so that in the brainstorming phase, you got to think about what kind of wood do you need to get, how are you going to cut the wood second, and what is going to be the brains of the operation, what electrical component is going to power your arcade. So electronic projects, huge part of it. All right, so now we're going to talk about Raspberry Pi, and I think I have a couple of examples. None that I can immediately pull out, but I suppose the picture here will serve. Raspberry Pi, you don't want to eat this kind. As you can tell by the picture, this is definitely a microcomputer. This is also known as a system on a chip. It's called that because all of the components that you normally find in a computer, which is like a jumble of wires, a clunky power supply, a overheating CPU, all of this is condensed onto a single board. And you can see here that the CPU there is in the middle. You have some GPIO pins for integrating with other electronics projects. There is USBs on the front. There's display, there's power. All the functionalities that you would find on a normal computer are also on this Raspberry Pi. Small form factor, it's easy to make the brains of any DIY electronic project. I'll show exactly where the brains are on all of my projects during the showcase, but you'll see that they're usually tucked away, out of sight. They don't interfere with the design of the project because they're just meant to be the quiet CPU that does all of the thinking. They're not really the center of the showcase. Used in arcade cabinets, robotics, and more. Project showcase. I feel like this would be a lot more exciting if you were here in person, because then you could pick up the projects and look at them and open them and interact with them in such a way that makes a lot more sense than me just talking about them. But given the new normal, I will make do with the resources I have available and try my best to kind of go over all the different projects that I've talked about here. Well, I haven't talked about them yet, but will talk about. I have with me today, let's start with the easiest one. A while ago, down in the makerspace, we were tossing around the idea of making a retro gaming kit, and you can easily throw one of these in an arcade cabinet that you built out of wood, but I thought that the idea that made the most sense to me during the brainstorming phase was I'm just going to make it small. I'm going to make it so that I can tuck it away, forgotten, and I also have controllers that work with it. You can hook up Bluetooth wireless controllers, or you can do what I did. I went on Amazon, I got myself a USB to SNES controller adapter, and those plug right into the front of the Raspberry Pi here, and also have built-in drivers for RetroPie. RetroPie is actually the operating system that is on this mini game system. It is a Linux-based operating system that you can very easily install using guides online. But yeah, there's the storage right there. That's where all the games are. That's where the operating system is. And the brains of the operation, can't really show it to you because it's hidden away in this case, and the case is also screwed together. So I feel like a good example of showing where the Raspberry Pi comes in is my laptop project. So I've been gesturing to this thing all stream, and it's codenamed QT Pi, and I really like just the fact that this is a finished, usable project of mine that I worked on for about a year. I started at HackYSU 2019, and I didn't finish it until immediately after HackYSU 2020. So let me see. We got power. All right, cool. So what this is essentially, I thought to myself, everyone, or I shouldn't say everyone, but a lot of people in the computer science field, they're really adamant about building their own desktop computer, and a lot of people make a hobby out of it. Essentially, I thought to myself, well, anyone can pick up the parts and find where the connectors go and build a desktop computer. How many people can say that they've built their own laptop? That was the brainstorming phase right there. That was the moment when I realized what my goal was, what my endpoint was, and where I wanted to go with this project. Then came the planning phase, of which I had to go through numerous times. Being that this is, I would consider one of my first big DIY projects, I had to think, what is the easiest way to implement a Raspberry Pi in a laptop form factor that doesn't cost a ton of money? Because trust me, there are solutions already out there where you can just pop a Raspberry Pi into this case, turn it on, and it becomes a laptop. But they're like the price of what you would actually pay for a laptop. At that point, just buy a laptop. But this I managed to keep, I'd say, just under 200. I'm not including all the times I had to buy a new screen because I kept breaking the screen foolishly. Like, that's not on the budget. Assuming that you do not break or shatter the screen during building it, should cost you about $200 to make something like this. And I can actually bring up on screen where I got these the files to make this from, because I didn't design the chassis for the laptop itself. I actually found it on a website called Thingiverse. I reached out to this user here, Slowmozo. I'm not sure how to pronounce that 5 in his name, but this was someone that I could reach out to, email, and collaborate with, because I didn't want to just, rip off their idea, but I wanted to be inspired by the compact chassis design that he implemented, because in his final result, there were a lot more wires than what you currently see in mine. I have exactly 3. I have 3 wires running in between my components here. I have 1 for display, and I have 2 for power. And the power going to a power bank, one of which going to the board driving the graphics, the other one going into the Raspberry Pi. He built his own battery system, and he wired the parallel batteries together. And I think he also implemented an off and on switch. In other words, this was a lot more involved than I got with my project. And I realized out the gate when I tried to kind of mimic what he did that I did not possess the electrical engineering skill required to really implement all of these features. So I went back to the drawing board. I went back to the planning phase of project management. And when you go back to the whiteboard, it's easy to feel defeated, especially after you had this great idea. You put it out in the open and it doesn't work out. At that moment, you have to make the decision, do I want to keep working on this, or do I want to try something else? Just throw it in the dumpster and work on something else? The answer to that depends on how passionate you are about your project and how much you're willing to see it come to fruition, because half the battle is just being passionate about what you've created. And that's why I'm so excited to share all of my toys with you today, because these are all projects that I was passionate about at one point. I lost my train of thought entirely, just being real with you. Right, so back on the topic of project management. When you go back to the planning phase, I realized I could not wire a battery together. I could not wire my own off and on switch, which, believe me, I tried. it did end up working for about 5 minutes, and then the solder came loose on this very cheaply made board that held the batteries together. And at that point, I realized there's no point in me waiting a month for another board to come in. So I decided to change tactic, go a different route. And that's when I got a dedicated power supply, which is the portable battery. And that is also when I decided that I was going to use a different screen than the Raspberry Pi Foundation screen, because not only did I kind of mess up the power system, that was also one of the instances where I broke the screen. So I had to find a more durable screen. I had to find a power solution. And one solution that I haven't really figured out to the fullest yet, you may have noticed that this laptop's missing something: keyboard and mouse. I'll come back to that in a bit. So fast forward to the second iteration of this laptop, less wires, more abstracted away concepts, such as taking the power system, just compressing it down into one component, taking the screen and getting a different board entirely means that more space was being taken inside the case. So I believe I did have to make some modifications to the 3D print that this gentleman uploaded, and that's when I remixed it and kind of made it my own. And after the second rendition, I realized that there was one last problem: the positioning of the Raspberry Pi itself. I'm going to bring it back on screen. Right here in this corner is the most optimal placing for the Raspberry Pi. I originally had it over here, and it conflicted with the logistics of everything. Like, everything I had organized up to this point did not come clear that I had completely not anticipated where things should go at all. So I rearranged everything inside the case. The wires fit a little bit better at that point. I was able to close the thing in, fully. And I think the last iteration was, and the one that you see here today, other than doing a paint job and putting a finish on it, was I needed to figure out keyboard and mouse. Well, I did find one solution, although it's not a physical solution. There is no keyboard and mouse on that because I use it as a companion device when I go to hackathons. What this means is that it's open next to my actual laptop. So what I decided to do was get a server program called Barrier, and through Barrier I can have my laptop set up as the host. I can have the Raspberry Pi laptop or Qt Pi set up as the client, and then I can use the keyboard and mouse on the Raspberry Pi laptop as if they were connected to the same computer. And that's been how I've been using it so far. I have yet to go back to the drawing board and scratch my head, how am I going to solder all the keys needed for a keyboard in a form factor that could fit in there. I'm going to have to approach that with the same cylindrical process of brainstorming, planning, implementation, and testing. The testing usually came from me using it as my sole computer as a hackathon at a hackathon. Like, this is what I'm doing my whole project on, and that's when I began to notice a lot of the flaws. All right, few more projects for this showcase, and I swear I won't go off the rails about these ones. These ones are fairly simple. You can use a Raspberry Pi as a server. I originally had this set up as a web server to put my website on, and then I found a better solution that I ended up paying for, and it kind of got rid of a lot of things that I was worrying about, such as my server going down and I'm not home. But this I have now set up as a media server because I have a whole bunch of media that I own in physical format that I have archived. And I thought to myself, it would be great if I could access this media from anywhere. So I looked into how to make a Raspberry Pi Plex server and found that Plex servers are very similar to web servers in the sense that you need to set up just a host. And it is this host that pushes out the content that you have on the hard drive here. And then you connect to it as a client. What I pulled up on the screen here is just Apache web server on a Raspberry Pi. If you have a Raspberry Pi lying around, or maybe someone gave you one as a gift, and you want to make a web server for yourself, you can make a WordPress website using Apache server. RaspberryPi.org has a wonderful resource that takes you step by step how to install Apache, install, I think it's SQL, whatever the Raspberry Pi equivalent of SQL is. And then you got PHP, which runs your programming, and WordPress. You make a local WordPress account that you log into on that machine, and then you have a website that you can only access from your home. All right. So that is, I don't really have a code name for this yet. It's been living by my router for the past 5 months. I've just been calling it my server. All right. And this here, you can actually play with, if you come down to the collaborative in our robotics makerspace, we have a Bluetooth robot that you can control from your phone. And this is an example of where they implemented a design that made sense for the brains of the operation, because under this shelf here, there are 2 boards, one stack on top of another, and I'm not sure how well I can convey that to the virtual masses, but you can see that there is one board right here. That's the Raspberry Pi board, and then there's a proprietary Yaboom board underneath of it. Actually, hold on, I can do better than this. Hold on. Let's go back to the other view. There we go. Right. So here we have our Yaboom board right there, and on top of it, that green board that you see is a Raspberry Pi board. The Raspberry Pi controls the camera on top here and all of the motors connected to it, whereas the main board controls the motors, the IR sensor, and I think there's a Bluetooth chip on here as well. So again, this is something that if you were interested in the world of robotics and how to implement a Raspberry Pi board into your robotics kit, this could be a cool thing to play with, get some ideas from, and start brainstorming your own robotics project. So if you want to come tinker with this, this is down in the Oak Hill Robotics Lab. All right. I think I very quickly went through a lot of that showcase. So we're going to move on to questions. All right, we are already at questions. Oh boy. So I'm gonna give it a minute for all of our loyal attendees to post their questions in chat if they had any. I'm known to ramble. I'm sure that if you've stuck with me for like the past 30 minutes or so, my voice has just become a drone, and for that I apologize. I feel like that I presented a lot of content in the showcase here, so if you have any specific questions on how I made something or how I applied project management to go from point A to point B to point C, feel free to ask. If you have any questions about Digital Inclusion Week moving forward, like the presenters tomorrow, Wednesday, and Thursday, what they're going to be talking about, that's something you could ask. And I don't know, ask me how my day went. I don't know. I'm just going to give it, let's say, 5 more minutes for questions to roll in, and that's the end of the stream. Thank you for tuning in. This has been the Day 1 Digital Inclusion Week, DIY with Raspberry Pi. My hope with this presentation here is that you take from it just the project management process and then apply it to your own projects, whatever it may be that you're working on, even if it's not electronically oriented. Okay, so what we have here is a question from George Tibet. I hope I'm pronouncing that name correctly. Will a Raspberry Pi Zero work instead of a regular Raspberry Pi? There are some variables that need to be filled in there. And what I mean by that is a Raspberry Pi could work, a Raspberry Pi Zero could work if your demand wasn't as high. So for example, with that robot that I showed earlier, the Raspberry Pi is responsible for, I think, 2 motors and a camera. I don't know how much processing power is required to run a camera, but the motors might, get it going just based off of pushing power alone. So I haven't experimented personally with using a Raspberry Pi Zero, but if you know the specifications of your project, and you would find these specifications through the planning process, if you know that your project only requires so much processing power, then sure, use a Raspberry Pi Zero. There are some instances in which case you value space over that processing power and you need a smaller board. So it's realistically dependent on what you're doing. All right. Ryan Lalchand asks, so what exactly were you using the companion Pi for at the hackathon? It's a good question. I had my IDE open. That's an integrated development environment. And I also had Unity open on my main laptop. And that's all that laptop was responsible for, was programming and working with the game files. Everything else that didn't fall into those two categories, I delegated to the Qt Pi. So I would say I had Discord open on this. I had my email. I had YouTube open because I was watching guides. I had various articles open. So I have a Raspberry Pi 4B, 4 gigabyte in this. And those 4 gigabytes of RAM really came in handy when I was running 10, 12 tabs at a time. But what I mean by companion Pi is that in order to operate it, since it doesn't have a keyboard or mouse, it kind of has to be like a vampire and use the keyboard and mouse on the laptop. So I think it's more of a companion in the sense of it cannot be run without the laptop unless I have a keyboard and mouse handy. All right, another question. This one is from Ian Granados. Do you know which Raspberry Pi would be best suited to manage an arcade system with the capabilities of playing classics like Pac-Man to maybe something a little more advanced like a shooting game as Area 51? I feel this just kind of relies on the system requirements of the arcade games, because I know that a lot of arcade games, they ran on proprietary boards, meaning that these computer boards were built specifically for this game and nothing else. And we've gotten so good at programming and computer science that we've taken these computer boards and we've converted them to software. There are such a thing as emulators now. So if the games that you want to play on this arcade system have an emulator and the system requirements for that emulator line up with the Raspberry Pi that you have in mind, then it should work just fine. Now, I can think of a few examples off the top of my head, like the PS2, for example. If there are any games on a PS2 that you legally own and have ROM dumped and you want to run this as part of your arcade, the Raspberry Pi cannot handle intense 3D graphics. So I would say all of your arcade games will perform the best if they are 2D platformers or just kind of like 8-bit retro games. So to answer your question more specifically, my arcade system that I have here, I built this using a Raspberry Pi 3B Plus, and all of the arcade games that I have on here run perfectly fine, full FPS, and I run like games that I own, obviously, for legal reasons. SNES, I have a Nintendo 64 game on there. I have some Game Boy Advance games, a lot of Nintendo games, essentially. And it's able to handle those with no problem. So if you're looking for a recommendation, the Raspberry Pi 3B Plus is both capable and affordable. All right. I think that's it for questions. I didn't see any others pop up. And unless one comes up before I end the stream here, I just wanted to say thank you all for tuning in and joining me for Digital Inclusion Week, Day 1. Tomorrow, same time, 6 o'clock, and same place, now that I've figured out all the niches that are involved with streaming. We're going to have Steve Kristen, retired AT&T representative, talking about digital data safety and awareness, specifically honing in on where is your child's TikTok data really going. That's tomorrow, 6 p.m., same place, same time. So thank you all for tuning in, and you guys have a wonderful evening.